Okay, so this is the key to topic 12, part A. And in number 1, you're given this relation, and this relation has 4 points. And you're asked to find the domain and the range, and then to determine if this relation is a function or not. Okay, so remember that the domain is the set of x coordinates. Now, this is a finite set of ordered pairs, so it's pretty easy to determine the domain is just the x coordinates. So keep in mind, though, since it's a finite set, you have to list it as a set. So you have to use those braces. And so you're going to say 10, 6 is the next one, 7, and negative 2. So that's your domain, the set of x coordinates. And it has to look like this in the brace. The same thing with the range. So in the range, you have your brace, and so you have this set, and so you have negative 3. It's each of those y coordinates. 4. Now, since negative 3 is already listed, don't list it again. So only list it once, and then 5. All right. And then the question is this relation a function? So the best way to do that is to remember this mapping that we talked about. So this is x, this is y. And so remember, a function is a relation in which for each x coordinate, there's only one y coordinate attached to it. So for example, when x is 10, I have a y value of negative 3, just like this. All right, so when x is 10, there's only one y value attached to it so far, okay? When x is 6, I have a y value of 4. So for this x coordinate, there's one y coordinate. For this x coordinate, there's one y coordinate. So you see that arrow that's pointing away from each of those x's. When x is 7, I have a y value of negative 3. Don't list negative 3 again. It's already listed. So that's why it's important to do the same thing here, okay? So you have 3 elements here. You have 3 elements here. And then when x is negative 2, you get a y value of 5. Notice that for each of those x coordinates, there's only one y coordinate associated with it. It's okay for a y coordinate to be associated with 2 different x coordinates. All right, so that's fine. So is this relation a function? The answer is yes, because for each x coordinate, there's only one y coordinate associated with it. All right, number 2. Determine whether the relation is a function. Explain why not. Okay, so let's do the same thing we did here. So let's go ahead and draw a mapping like this. So we have x and y. And when x is 6, it gets mapped to negative 2. When x is 5, it gets mapped to 3. So far it looks good. For each of those x coordinates, there's only one y coordinate, but that must be true for this whole relation, every point in the relation. When x is negative 7, it gets mapped to negative 8. When x is 4, it gets mapped to 0. When x is 5, now remember, I already have 5 listed, so don't list it again because you're going to mess up. So it's already listed. So when x is 5, it gets mapped to 6. And so notice that when x is 5, there are 2 different y coordinates. The definition of function says that for each x coordinate, there must be only one y coordinate associated with it. So the 5, when x is 5, that's our issue. There are 2 y coordinates associated with it. So the question is this relation a function? The answer is no. And you're going to say something like this. You're going to say when x equals 5, there are 2 different y coordinates. Okay, so something like that. And you could be a little bit more specific. You could say the y coordinates are 3 and 6, something like that. Okay. All right, number 3. This time you're given an equation, and you're asked, does this equation define y as a function of x? So basically, if you get y by itself, is what you have a function. And so notice the way you want to think about these is your past experience. So notice that this is a linear function. In fact, when you grab this linear function, if you think about it, y equals negative 3x plus 4. So when you grab this, notice the slope is negative 3 and the y-intercept is 4, right? So when you graph it, your y-intercept is 4. So to graph a line, you need 2 points, so 1, 2, 3, 4 right here. And then the slope is -3, so that means you go down 3, 1, 2, 3, and to the right 1. And so there's the other point, and so you get this line. And so notice that it passes the vertical line test. Okay, so passes the vertical line test. All right, so that is a function. It's a line. In fact, the only line that's not a function is a vertical line. Just remember that. The only line that's not a function, that does not represent a function, is a vertical line. All right, so for example, something like this, x equal 4. X equal 4 is not a function. The graph of it does not represent a function, because remember, this means that x always equals 4 no matter what y is. All right, so you learned that in a previous course. So if you graph this, you get 4, 0, you get 4, 2, and so notice that's a vertical line. And so you notice it fails the vertical line test, because the vertical line test must intersect the graph only once, and it intersects the graphs an infinite number of times. You can also see it from here. Remember, the definition of function says that for each x coordinate, there must be only one y value. Well, notice there's an infinite number of these, -6.5. Okay, so and so on and so on. So there's an infinite number of these right here. Okay, all right. So the only line that's not a function is a vertical line. Okay, so this will be yes. Okay, now here you have to remember something about this. The way I wanted you to think about this was to notice that's the equation of a circle, right? That's the equation of a circle, x squared plus y squared equal 25, where the center is the origin and the radius is 5. And so if you graph this, there's the center, so the radius is 5, so you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And notice that this is a circle, and it fails the vertical line test. All right, so the way I wanted you to do this was to remember what the graph looked like. So the answer is no. Remember, this is a circle. Okay. Now the other way you could do this is this way. So you see how y was already by itself here? You can get y by itself here. And so that was in one of the lessons. If you go back to study those lessons dealing with this, if I get y by itself, I'm going to show you something. So we're going to bring the x squared over. So I get y squared equal 25 minus x squared. Then to get y by itself, I have to take the square root of both sides. But remember, when you take the square root of both sides, you get plus or minus. So the squaring and the square rooting undo each other. So you get y equal plus or minus the square root of 25 minus x squared. And then see that plus or minus was important. Okay, so right away you can tell that that's not going to be a function, because you get a positive value and a negative value for y. So for example, if x is, let's say, 1, just use 1. Okay, or you can use 0. It doesn't matter, guys. It does not matter. Watch. If x is 0, watch how easy this becomes. So this becomes a positive square root of 25 minus 0 squared and a negative square root of 25 minus 0 squared. So in place of x, I substitute 0. Well, 0 squared is 0. So this becomes a positive square root of 25, which is 5. Here, this becomes a negative square root of 25, which is negative 5. So notice that when x is 0, there are 2 different y values. So that's not a function. All right, and it actually corresponds to this. You see this, when x is 0, there are 2 y values, 5 and negative 5. That corresponds to this, by the way, right here. When x is 0, there's your 2 points that they're referring to. You get 0, 5, 0, negative 5. That's what that's referring to, this right here. When x is 0, you get 5, and you get negative 5. That's this. When x is 0, you get 5, and you get negative 5. Okay? All right. And then number 4, all they want you to do is just use a vertical line test. So notice this passes a vertical line test. So for each x coordinate, there's only one y coordinate. This fails the vertical line test. So the answer is no. Okay? All right. So that is the key to topic 12, part A.